has a question on, if somebody has a question on a comment, uh, we you can ask then, so that we can go on, or we can go on and then we can have the questions later, if it's okay. So the DAO was the largest crowdfunding in history, having raised almost 150 million plus from 11,000 plus members. The DAO is the name of a particular decentralized autonomous DAO conceived and programmed by the team behind German startup Slock It that builds smart locks to let people share things, car, boats, apartment in a decentralized version of like that of Airbnb. So the DAO was launched on 30th April 2016 with a 28-day funding window. The DAO was the largest crowdfunding in history, offered and sold approximately 1.15 billion DAO tokens in exchange for a total of approximately 12 million ETH, valued at approximately 150 million from 11,000 plus member. It can be said that the marketing was better than the execution. For during the crowd sale, several people expressed concern that the code was vulnerable to attack. So this is one of the reasons why I was telling you that when you are investing in a project, don't just consider the community, but also the code itself, or the developers who are involved in the development of these projects. So most of the questions maybe you may ask is, has the contract been audited? So I mentioned Open Zeppelin. There is same. I think something. Let me share the links. So we have systems. So these are also smart contract editors, I think, and then we have Open Zeppelin, Open Zeppelin. You have Open Zeppelin, who are also smart contract auditors, who are also smart contract editors, auditors, I mean. So you have to ask yourself, and so they normally deal with security audits and everything, and also they have templates that you can use for your smart contracts, mostly like the safe math, the time lock, the governance, the owner.sol. You can use it for that. So most companies do their code are audited by Open Zeppelin. So these are some of the questions that you may ask: whether the smart contracts have been audited, and if they have gone through a testing process, and if they are vulnerable. So as you can see, from this, some people had raised concern over the vulnerability, that the contracts were vulnerable to attacks. So these are some of the things that you take a look, because you may have the good marketing team, you may have you may have a good community, but you don't have good developers. So it has to go they have to go together. They have to go together. So I'll share the link for Open Zeppelin. You can take a look at your own time and see who they deal with, and yeah, they also do offer courses on security and everything. Yeah. So then we have, so going forward, so this is how the DAO initial offering looked like, and how the project and say token monetization process was. So we had the initial offering, that is the DAO, and then we had the redemption process, how you could redeem your DAO tokens and currency DAO entity split. And then we had the investors, and then this was the like the centrally markets, and then we had the founders. These were the founders. So once before, you were supposed to like you were supposed to like be an investor so that you can be able to redeem your tokens. And then there were project proposal, and then project proposal plus the deposit in ETH, and then there were approval, the normal functionalities of a contract, the normal design process of any 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 project, but specifically this one was for crowd. Yeah. So uh, so the DAO was aware of the reentrancy vulnerability, but misjudged the potential impact. So these are some of the comments and publication that they had on Medium, on their Medium. So our team is blessed to have Dr. Christine and founder of Solidity as its advisor, Julian. So they were very positive and very sure that the vulnerabilities was not that big. So once the crowd sale was over, there was much discussion of first addressing the vulnerabilities before starting to fund proposals. In particular, Steve Han Taul, one of the creators of the DAO, announced on June 12th that recursive callback had been found, but that no DAO funds were at risk. So they still believe. So this recursive callback is a very bad bug, because it continues to like it continues to like it continues to like it's recursive in a way that let me show you an example in code. So recursive, yeah, these are, so these are like a function that you can use. And so the attacker creates or join a split proposal with the recipient address sent to the wallet contract created above. The attacker votes yes on the split proposal. After the split proposal expires, the attacker calls the DAO, split DAO function, and then the function calls the wallet contract default function as part of the sending the ETH to the recipient. The wallet contract's default calls the, which repeats the circle. So it's a process that like loops. It's like a continuous loop. It's like a continuous loop. When you have a recursive bug, it's very bad, because your token can if somebody finds a vulnerability on your code, those people will be able to manipulate and also be able to like, it's like when you're in an ATM, and then you manipulate the ATM to like withdraw your cash. So you do the first withdrawal, and then the account balance is not updated on your on the bank on the bank ledger. So if the balance is not updated, it means that you can be able to do another withdrawal, and then you can continue doing that like the whole day. And then if there is a recursive bug in even in the normal systems like the bank ATMs and the phone, yeah, that's how bad the bug is. Yeah, so and they said there was the DAO funds were not at least. So at the time, more than 50 project proposals were waiting for the token holders of the DAO to vote on them. But by exploiting the entrance vulnerability, an attacker managed to drain like 3.6 million plus ETH from the DAO contract. So you remember they had managed to raise like 12 million ETH in their crowd sale. So this guy was able to like withdraw, continue withdrawing. So a known attacker began exploiting the reentrancy vulnerability to start draining the DAO of the ETH collected from the sale of its token. By Saturday 18 June, the attacker managed to drain more than 3.6 ETH worth of they were worth at the time they were worth 70 million US dollars into a child DAO that has the same structure as the DAO. So you see, from the other one, what I had explained about reentrancy vulnerabilities, that somebody can create another contract that is similarly to this one, and using recursive code, they can be able to now like manipulate or kind of create a process which looks the same as the original one. Yeah. So the price of ETH dropped from over 20 USD to under 13 USD. So this made them to do the DAO fork. So all eyes were on the DAO and the Ethereum Foundation to resolve the issue and resume business. The DAO contained roughly 15% of all ETH either. So a failure of the DAO would have negatively impacted on the Ethereum network and its cryptocurrency. Dozen of dozen of startups were working on the DAO or governance product. Many smart contracts had similar vulnerabilities. So this one was actually most contract and had this vulnerability, and including ours that was in 2018. It had the first contract that I created had the same vulnerability, and we had to redo it again with new measures and better code from Open Zeppelin. And building complex software using smart contract were still in its infancy. So all eyes were on the DAO and the Ethereum Foundation, hoping for a resolution that would allow the ecosystem to continue to develop as it had been before. So this decentralized autonomous organization, if it was a very big company, because they were able to like raise 12 million ETH. Right now, that's a lot of money, and you can see there were people who relied on it. It was like go fund me or something like that. Yeah. So then a soft fork proposal was a good news for everyone, but it turned out to be unfeasible. In order to prevent the hacker from cashing the ETH from the child DAO after the standard 28 days, a soft fork was voted on, and it was really close to being introduced. A few hours before it was supposed to be released, a few members of the community found a bug with the implementation that opened a denial of service attack vector. So you see, as since some of you will be smart contract developers, so it's good to like plan your system, do big testing, do a lot of testing before you release your product or your software, because you see now this attack actually brought about another attack, which is denial of services. And if you have denial of service, you cannot be able to like continue using that. You are in access, you cannot have access to your smart contract. So this soft fork was designed to blacklist all the transaction made from the DAO. And the fact that such a soft fork was not possible to implement meant that the Ethereum blockchain was immune to transaction censorship. So immune to transaction censorship means that you cannot be able to like censor specific transactions. You cannot hide, you cannot like blacklist transactions. So it meant that the Ethereum was actually immune to this form of blacklisting. The Ethereum Foundation did not design the network to be the judge and jury when some parties go injured. So the Ethereum Foundation had a lot at stake there. They wanted the network to be lock solid to support billions of dollars worth of commerce and to be the operating system of the future. If they did nothing, the Ethereum network would suffer a setback that could take years to recover from. If they intervened, they would set a dangerous precedent that eroded the social contract they set up with their network of the independent node. Yeah, so they had to be very careful, and then that's why the best way to do a fork for such a network is by invalidating some block and creating new blocks. So this guy was lucky. So the attacker withdrew ETH from the DAO multiple times before it could update its own balance. This is what I was explaining with the ATM scenario. So this attacker would be able to withdraw. The attacker would be able to withdraw ETH, and then the balance wouldn't be able to update. Then again do the same, withdraw, and then the balance wouldn't update. So if such a thing happens, you will be leached, because uh, you would be leached before they fix the system. So the attacker withdrew ETH from the DAO contract multiple times using the same DAO tokens. This was possible due to what is known as a recursive call exploit. In this exploit, the attacker was able to ask the contract DAO to give the ETH back multiple times before the contract could update its own balance. So also while creating your smart contract, you have to check to be sure how you pass or how you store your balances, how you do map your balances on your smart contract. This is very important. Yeah. And most of the contract, if you don't want something to be like returned, or if you want to, like, you can create a fallback function that or an assert function that prevents certain if the smart contract from uh, being called by other or being exploited. Yeah. So there were two main issues that made this possible. The fact that when the DAO contract was created, the coder did not take into account the possibility of a recursive call, and the fact that the smart contract first sent the ETH funds and then updated the internal token balance. So it should be fast. If somebody clicks on the function to withdraw, the balance should be updated first, and then the other side, it should be synchronous. Is it? Yeah, synchronous. Like, it should be something that is happening simultaneously, like pamoja. Yeah. So if somebody clicks the function to withdraw, the balance is updated at the balance is updated at the bank, and then later updated on your phone. So it should follow a sequence, and it should it should first check whether you have the balance. If you don't have the balance, then it tells you that you don't have this kind of balance, and then you so these are some of the exploit. And you remember that when you're doing this, always put your mind that you are managing people's money. You are not managing your own money. You're managing people's money. So if you're creating a smart contract, always put that in mind, that you are managing people's money. So if anything happens, these are people's money you're putting at risk. Yeah. So that's how the attacker was able to do that. So this one is a simplified representation of the DAO smart contract. So we had this the contract DAO, the name of the contract. This declares a state variable that stores the token balances for each possible address. This is how they were mapping the address, and these balances were private. And then this was the function to withdraw. To withdraw the amount given in the parameters from the contract. So this was the function to withdraw a net amount of ETH or DAO. The balance of the sender must be more than the amount there to withdraw. So your balance that you want, the balance, the amount of money you want to withdraw has to be equals or greater than what you have in your, it has to be greater, has to be, let's say you want to withdraw 10 DAOs, and your account balance has less than 10, it should prevent you from withdrawing. It should prevent you from withdrawing. So some contracts don't have that. So if your balance is less than 10, if your balance is less than 10, there are some contracts that had the same issue. So people would still withdraw. So let's say in your bank you have like 5 DAOs, or in your contract you in your wallet you have 5 DAOs, and then you want to withdraw 10 DAOs. It should actually revert. It should actually revert and tell you that you don't have enough funds. So if this part you program it bad, people will still be able to withdraw those tokens. People will be able to withdraw those tokens. So you must be very careful when you are mapping balances, and when you are creating the function for withdrawal. So and then the balances has to be the balance that you have in your smart contract or in your wallet has to be greater or equals to what you want to withdraw, or what you want to withdraw. Yeah. Then invoke the callers function using the amount to withdraw as the parameter. Represent the fallback function, this one. So reduce the token balance of the sender by the amount withdrawn. Then you have to minus the balances. So this one, of course, has been upgraded. This is not the way the function to withdraw and function for mapping looks like, for mapping addresses look like. Let me see if I can be able to get some code and show you how now the function, the function for withdraw, how it looks like. And yeah, I've gotten something. So scripts, no. We have source, contract, and then we have token. And then let me share. You share. Yeah. So let's see balances. Balance of, yeah. So this is the balance of, so this one tracks the balances. This one tracks the balances of this one is the balance of each and every address. As you can see, there is a differences, because this one is uint 256 and this one is uint technically uint and uint 256 are the same. By default it's uint 256, and then the balances are public, but this one tracks the balances and should be immutable, should be exposed for public viewing, and has to be uint 256, which is must be positive. So there are some contracts, if the value is there are some contracts that used to go with negative values. When doing some testing, you have to also check it out. And then we have the function to withdraw. So withdraw. Withdraw. Withdraw function, withdraw, transfer. This one does not have a function to withdraw. Yeah, it's in this exchange. So also this one, contract exchange has the mapping for all the tokens. It maps all the tokens that are in that particular contract, and also this one does the same for mapping the orders. It's basically the same. And then we have this function for withdraw. So this is how the function withdraw looks like. So first of all, you have to require the amount the sender has, and then you have to check the tokens and the ETH. This one is for withdrawing ETH. So you have to check the number of ETH the user has. That is represented by message.sender. And then you check the amount. So this one is like this one, checking for the balances. Checking for the balances. If the user has the greater or equals to that amount of balances. And then this subs comes from the safe math. This one, safe math, which I said safe math is a smart contract that is used for subtracting the amount. So you have to subtract the amount the user wants to withdraw, and then you invoke the function for transfer, so that they are able to transfer the amount, and then you transfer the event, or you emit the event for withdrawal. So this is how the withdrawal looks like. This one. So it maps the addresses, the address and token, the address of the token, and then it also maps the address of the user and amount of the token, and then the balance of the token. So you have to put it in that sequential order, so that you are able to, like, people are not able to manipulate your smart contract and withdraw multiple times. Now imagine this happens to an exchange, either a decentralized or a centralized exchange. If this happens to an exchange, then it becomes very, very hard for the exchange to even actually recover from such an attack, and they will be counting losses. So you have to be very careful when you are creating your smart contract. You must be meticulous, and yeah. So this was an example of a good implementation. Yeah. Then we have something. Okay, it's recording. So the transaction will invoke a wallet smart contract interacting with the DAO smart contract. So this function that I've talked about. So, and then this is the wallet contract. So a function do withdraw like 1,000 DAOs, 100 DAOs, and then function event money received should show you the amount, the money that has been received. So if you can look at this one is this one will be will be vulnerable. And then balance of the address, the first address is 0. So if the user if the user does that, the user the wallet address should also be updated. And then the contract the DAO contract is supposed to be updated also. So it should be minus 100 here, and the balances of the contract should be 100. So the transaction will invoke a warrant contract interacting with the DAO. So this is the attacker's address. So he will do the same thing again and again and again and again, because this one, there is no way you can be able to like from what we have seen from this other one, there is no way they are also mapping the balances of the contract itself, or the token itself. So they will keep on doing that and doing that until this is how they say some of the tokens are actually created out of the thin air. If this money is not available on the contract will start like creating other tokens which are not there. So these are big problem. These are big problem, even when it comes to money, which is money, ATM money, or banking systems. That is the mobile transfer, the same with mobile money transfers. This is something that is supposed to be taken care of or looked at in a very detailed manner. So the hard fork proposal was controversial among the Ethereum community, causing the birth of Ethereum Classic. A more conclusive hard fork solution was then put up for vote. This hard fork had the sole function of returning all the ETH taken from the DAO to a refund contract, with a new contract having only one function, that was for withdrawal. The DAO token holders can request to be sent 1 ETH for every 100 DAO. This proposal created a lot of controversy among the Ethereum community, which was split into two groups, supporters and non-supporters. So this is how the birth of Ethereum Classic was, or how the splitter group from Ethereum to Ethereum Classic was born. And yeah, because some felt like they never wanted to like return the money that was like stolen, and the others felt like there was a need for a return of the money, and then there was a need for a hard fork. So Ethereum Classic was I think was for non-supporters. Yeah. Then we have securities and exchange. Securities and Exchange Act of 1934, release number 8207, July 25, 2017, report of investigation pursuant to Section 21 of the Security Exchange Act of 1934, the DAO introduction, and this is the Securities and Exchange Commissioner, Commission of the US. That followed they followed this act of 1934 on how the should be like see the DAO attack, how they were to do that. Yeah. So these are regulation policy or an act that ensures that things are done accordingly. So we have another one, and that was the parity wallet hack. And this is how they were able to hack. The first parity wallet attack was in July 2019, resulted in a loss of 13 million USD. On Wednesday, July 2017, a bug found in the multi-signature wallet, multi-sign, multi-signature wallet are wallets that can have multiple wallets, like MetaMask. Code used as part of the Parity Wallet 1.5 software was exploited, resulting in 3 out of 596 vulnerable multi-sign wallet being compromised, losing 153 153,000 ETH worth 30 million USD. Then we had the 78 million USD worth of tokens and 377,000 plus ETH, around 72 million that were potentially vulnerable to the issue were recovered by the white hat hackers and returned to their rightful owners. So these guys are good guys. The white hat hackers are good guys. The bug was in a pair of functions designed to allow the setup of multi-sign wallets in Parity Wallet software. The bug was in a pair of extremely sensitive functions designed to allow the setup of multi-sign wallets in the Parity Wallet. The function should have been protected in order that they be usable only in one specific circumstances as the contract was being created. However, they were entirely unguarded, which allowed the attackers to reset the ownership and usage parameter of existing wallet arbitrarily. Through the code, though the code was open and public, and thus the bug could have been discovered, reported, and fixed before any damage done, there were no incentive to ensure good-natured eyes from the community inspected it. So the attacker obtained exclusive ownership of the multi-sign wallet through changing the constructor function. The attacker sent 2 transactions to each of the affected contracts. The first to obtain exclusive ownership of the multi-sign, and the second to move all of its fund. So this is the constructor just pass on the owner array to the multi-owned and the limit today limit. So this is the function initial address and then owner and then in it day limit and then int multi-owned owners. So the function was probably created as a way to extract the wallet's constructor logic into a separate library. The wallet contract forwards all unmatched function calls to the library using a delegated call. So a delegated call dedicated call uh, give me a minute. So delegated call is an operation code. OP codes are useful in allowing Ethereum developers to modularize their code. Standard external message calls to contract are handled by the call open, whereby code is learned in the context of external. The feature enables the implementation of libraries allowing to deploy the usable code once they call it from function. So dedicated call, you can create a dedicated function if you are looking to upgrade your contract. But sometimes the delegated call can lead to unexpected code execution, and this is what happened. So the attacker changed all public function from the library, including initial wallet, to be capable to be callable by anyone, So anyone could be able to call that function. And unfortunately, init wallet has no checks to prevent an attacker from calling it after the contract was initialized. The attacker exploited this and simply changed the contract's M owners. Yeah, yes.
Hello?
Hello, yes, I can hear you.
Yeah, I'm just wondering if a system like this,
Mhm,
attacker can break in and move out funds from wallet.
mhm,
I thought there ought to have been a kind of authentication in place, in the normal Unix or Linux environment.
mhm.
For you to break into an account, you must have some degree of authentication to that account. Maybe the password, some few questions,
Okay.
maybe.
Uh, so most of these attacks happened to smart contracts. Most of these most of these attacks happened to the smart contracts, meaning that the creators of the smart contracts were the one who are not diligent enough and who never tested their code enough. Sometimes when you are developing, when you are developing a system, you may have a client or a boss who has excited the community and wants the product to be published early enough without having even testing. So, uh, in terms of authentication and in blockchain, you don't need a lot of authentication because you see what we did with MetaMask. There was no KYC that we did. We never inputted any records on of our own. Yeah, and that is one of the problems with wallets. That is one of the problems with wallet. So there are people who develop wallets initially to like aid an attack, especially when it comes to private exchanges, or not private but centralized exchanges. Centralized exchanges generate a wallet for you and they manage the wallet for you. They kind of manage the wallet for you. So when there is an attack on the exchange, uh, they are able to like find a way to get all your private key. So the attack does not generally have the attack does not happen direct to the system because the system is immune to attacks. They normally happen to different parties, to different not parties but different smart contracts which are being run on the system. Yeah. So there has been several attacks and there has been several proposals to improve the securities of the system because they came up with a way that the users should be in charge of their own private key. The users should be in charge of their private key. For MetaMask, right now, I see these days they are generating one phrase word for all your wallet. So if you create multiple wallets on the MetaMask wallet, you will have only one code to manage all that, like one password to manage all that, which is good because attackers don't won't be able to get access to such. Yeah, yeah.
It's
Uh,
okay. It's okay. It's
yeah.
okay.
So yeah. So the let's go on. The attacker
Hello. Okay.
yes.
One more thing. One more
Okay.
thing.
Okay.
Can we conclude that even the attacker might be an insider,
Yeah. Yeah.
as
Yeah.
in part
Yeah.
of a development team that
Yeah. Yeah.
maybe things went wrong and they just decide to show the people that look,
Yeah,
this is
actually,
happening. And
that is something which is popular in blockchain industry, and
okay.
there was an exchange. I don't want to mention the name of the exchange.
Okay.
But there was one exchange where I think not an exchange, but a project. There was a project that was being done. They had actually done a lot. They were creating a decentralized e-commerce. They were creating a decentralized e-commerce. So the project had good developers, and the project was kicking off right well, because I was actually following the project because I wanted to kind of create the same thing they were doing.
Mm.
So there came a point whereby the developers were not being paid.
Mm-mm.
So the developers were not being paid, and then they did something to the project. They actually withdrew from the project. And another one is some of the African project, which I have seen. I have seen some several projects whereby especially there is one project here in Kenya where the CEO created a smart contract which they never verified, verified on Etherscan. And then he said that he is creating this and that, and they were able to raise a good enough a chunk of money, whereby the CEO actually fled with the money, where the CEO fled with the money. So you can see for the developers can cause a downfall of a system, and on the other hand, the owner of the project or the investors of the project may even contribute to the fall of the project. And most of the African blockchain based project has been the same. And there is also another project that did the same, where the attack was actually done by the developers themselves, who actually withdrew those for especially for centralized exchanges. Especially for centralized exchanges, the developers have access. There was a company that I was in talks with, and I wanted to create my own decentralized exchange, but I had no access of the backend. I had no access of the backend. So that made me not to trust them, because if they are the ones who are controlling the backend and I don't have
Mm.
access to the backend, I myself as the person who is creating the project, then yeah.
Mm.
So that's why we have had decentralized exchanges, and we have like Uniswap. For example, Uniswap has a Gitcoin community, a GitHub community, whereby they have developers who are contributing to their ecosystem, and also they are open when they want to do an upgrade of their system and everything. They normally say that this is what we have done, this is what we are doing, this is what we intend to do. Such kind of engagement with the community. If there is an
Yeah.
update, they tell you, yeah, because this thing is decentralized, and if blockchain is decentralized, then such information should also be decentralized, and people should be, yeah. So
Yeah.
that's the one problem we are having in blockchain, because some people have nice ideas and great project, but at the end of the day, those projects have they have made this they have made blockchain to as a get quick get rich quick
Quick. Hmm.
scheme. They come up with awesome project. They come up with some awesome name, you know, and then at the end of the day, you
Hmm.
realize that this coin was also just another way to get rich. So
And
these are the
another
guys.
scam.
Yeah, yeah.
Hmm.
Yeah, but it's good to know all these lists and everything which is pertained, and that's why I keep on saying that when you are investing in a project and you are investing your money in something like in a token and everything, you have to do your own research. You have to know who are funding this project. You have to ask question about the security of the smart contract and everything. You might not know the technicalities of their project, the way they have structured their project, but if you ask, you will be able to get the answers. Yeah, you have to get the answers. Yeah, you will get the
Great.
answers. Yeah, so that you invest in a project that you know it won't get a point uh, whereby you will lose your coins. Recently, Mark Cuban, who is a billionaire, invested in Titan. Yeah, he invested in Titan and he lost. He lost
Hmm.
very badly. He lost. Yeah, he lost. He was hit hard. Yeah, he was hit hard, and even for billionaire you can see they have the same. So
Hmm.
that's what they are calling lag pooling in DeFi, lag pool, where developers create something and then they do a lag pool and kind of
Hmm.
uh, kind of making the project fail so that they enrich themselves and then go away or something.
That's terrible.
Yeah, yeah. So you must know the intentions of the project and everything. Yeah. So but some of these things, but also it goes back to the ethics. As a developer, it goes back to your ethics. If you have good ethics and you follow the ethics and everything, if you create something, you just move on and
Hmm.
yeah, if you want to continue contributing to the project, just contribute and you know, yeah.
Oh, well. Hmm. It's okay.
Yeah. So yeah. So let's continue. So the attacker exploited this and simply changes the contracts M owners state variable to a list containing their addresses. So and requiring just one confirmation to execute any transaction. Then we have after that it was just a matter of invoking execute to send all funds to an account controlled by the attacker. So this is the initial wallet of the attacker, a random attacker in the network. And that's why proof of stake is also good, because with proof of stake, you are actually bargaining with your coins. So if you do want to attack your system, your coins will be the one invalidated. Your coins will be invalidated and you will not have no money. So if you try to do that, that's why proof of stake is also a good way. So that's why the proof of stake is also good. So this is the correct owner before the attack. So this is the wallet with methods, withdraw and payable, and no initial attack method. So after the attacker using the delegate call, he changes everything to his own changes the owner, and then he is able to like send the money to his own wallet now. So this execution was automatically authorized since the attacker was then the only owner of the multisig, effectively draining the contract of all its funds. The second parity wallet attack happened on November 6, 2017, and it was locked up one 150 plus million. On Monday, November, a vulnerability in the library smart contract code deployed as a shared component on all parity noticing wallet deployed after July 2017 was found by an anonymous user. The user decided to exploit this vulnerability and made himself the owner of the library contract, subsequently killed the library contract, and the user decided to exploit this vulnerability and made himself the owner of the contract library and subsequently killed the library contract. Since parity multi-sign wallet depends on this contract, this action blocks fund in like 587 wallet, locking up a total of amount of 513 ETH and additional tokens worth 150 plus million. Subsequent to destroying the library contract, GitHub user DevOps 199 posted issue 6995 that promoted the investigation into the matter. So this is now why some of the reason why some, and since uh, and since some of most of this project are open source, that's another shortcoming of open source project. But these days I'm seeing there is a good response with the decentralized communities, with people like Gitcoin, whereby you contribute to an issue and you contribute to bounty hunting and everything, and then you get paid. This is a good way because people will now, it's encouraging good behaviors in the system. So this is one of the problem. And also this is another thing that I was saying, that you need to have a community of developers, people who will like identify that there is an issue on your smart contract and be able to solve and say that this is what you're supposed to do in your contract code. Because if you don't have a community of developer and you're treating developers just like they are just there, then you will lose a lot. And I like the fact that Uniswap is doing a great job with rewarding developers, yeah, and also Gitcoin. So the library code was put out there and left defenseless due to failing to initialize the owner. So you have to let me show you what I mean by that, by this owner. So let me share my browser. Share browser. So share. Yeah, so this is the browser. We go to either. That's kind. Yeah. So this is the Ubricoin smart contract. This is the Ubricoin smart contract. And if you go to read contract, you have to initialize the owner, or you have to state the owner of this contract. So this is the owner. So this is the owner of this particular contract. This is the owner of this particular contract. So if we had left this variable empty, and somebody was keen enough to take a look at our contract, they would have come to this part and they would have been able to claim the ownership of the contract. So here, So here, if I try to change the ownership of this contract, I cannot be able to. If I want to light on this smart contract, I cannot be able to light. There are functions that are only like this one for halting. If you want to unhold and hold the contract, they can only be done by the owner of this contract. So this is the kind of vulnerability they were able to find. See, so these are some of the things that I was saying, that you have to be diligent enough. You have to do everything. You have to like have a checklist. If you're writing a smart contract, have a checklist. Created ownership check, something like that. You have to go check in. So if I want to hold this contract, I cannot be able, because I'm not the owner of this contract. Let me try and see. Yeah. So if I try, yes. So if I try to light to this contract, I won't be able. As much as I try as much as possible, I won't be able. Let me just change the network to Ethereum and then use this one. And then I try now. Okay. Let me just use the other part. The other side is much. Oh. Contracts. Let's connect. And then now, if I try to hold this contract, so of course the MetaMask wallet will be revoked. And currently I have insufficient gas. But even if I had sufficient gas and I tried to do that, and I tried to like write into this contract and hold it. So if I hold this contract, nobody will be able to do transfer, nobody will be able to do withdraw, nobody will be able to burn tokens, and nobody will be able to like do anything from this contract. So this can be, if this function was created without having inputted the owner on the contract, like this. Let's just go to the code itself and show you. So if that function hold, so this is hold and it's public, but it's modified. It's only it's stop none, owner is emergency. So only the owner can be able to change this. So this is the owner, and then I have said it to revert. I have said it should revert. So if it's not the owner, it should revert. It should not proceed. It should not proceed if it's not the owner. It should be equals to owner. If not equals to owner, it should revert, and it should not go. It should not proceed. So these are some of the things that I was talking about, that you have to be careful, and you have to know what you want to do with. You have to know the type of functions that you are implementing in your contract. So if this part was not there, if this part was not there, then definitely as an attacker or a malicious person, I would have found a vulnerability. I would have withdrawn all the ETH, because I would have withdrawn all the ETH. I would have minted all the tokens and gone away with the token. So this is what we say, that the contract holdable is ownable. Ownable means it's owned, it's owned, and only the user can, and only the owner can change this function, to it's the only person who can be able to hold. So this is another one with a revert. It has a revert function, and these are modifier. only in emergency. In case there is an overflow error, in case there is something, then uh, then that's the only point that this function can be used. You hold that contract until you have upgraded. So as you can see from the comment, I said that the called by the owner on an emergency triggers stop state. Then called by the owner on end of emergency returns to normal state. So the contract will remain into normal state. And here I've said it's external and only the user, only the owner can do that. Also this one, only the user, the owner can do that in case of emergency. And then the modifier states that when the it's not the owner of the contract, then it reverts. If it's the owner, this modifier is for stop in emergency. If it's the owner of the contract, it holds the contract and reverts without going further, without executing any other code. Yeah. So that's how that's how the some of these exploits are done. So most of them happens on the contract side. Yeah. So let me go back to our notes. Screen share. Yeah. So I hope you can see the slides. Yeah. So there are other, there are other libraries like SafeMath is a library. Uh, there are many libraries, and yeah. So however, and this is a big however, the bug that was exploited was that it allowed an owner to get set the first time calling it. So the only way that the attacker could have taken ownership is if parity wallet contract was deployed without an initial owner. So if we had deployed the contract the same way I've shown you, without an owner, then this actually means that this hack was actually made by, or was done by somebody who knew the contract inside out. Because for me, I wouldn't take much time going through the contract code unless I have particular interest in a code. Yeah. If I have an interest in a code, in a smart contract, then I'll be able to go through that contract code. But if I don't have interest in that code, I wouldn't be able to know if. So is that a bug in the code or a bug in the deployment process? That is a bug in deployment. The library code was put out there and left defenseless due to failing to do the next step to initialize the owner. So that was it on Lisk. That was it on Lisks, and that was it on lists on Ethereum. So this marks the end of the Ethereum ecosystem, the final part of the Ethereum ecosystem. So it's a big the Ethereum ecosystem is big, and yeah. So I will recommend mastering Ethereum to get to dive more and know a lot about the inner workings and the most of this vulnerability. So we will touch on them on later topics. Yeah, on later topics. So in the book Mastering Ethereum, they have spoken in details about the vulnerabilities, about the solutions, and how you can protect your smart contract from such security vulnerabilities. And also I'll show you some of how you can be able to protect your token from such vulnerabilities. Yeah. So that is it on Ethereum ecosystem and the risk in the ecosystem, especially in smart contracts. Yeah. So I had planned that I'll introduce a little bit on lesson 4. So lesson 4 we'll see and talk about more on wallets and cryptography. We'll talk more on cryptography. We'll talk more about cryptography and wallets. Yeah. So hopefully this one we will do it tomorrow. We'll do it tomorrow. So yeah. Yeah. And then in this one, we will write a simple cryptographic hash for hashing passwords, and yeah, for hashing passwords. A simple cryptography for hashing passwords, because basically seed phrase or a recovery phrase are similar to password in such a way that you can be able to recover your password in a normal, in a web 3, in a web 2 based application, because the passcode or the encryption is stored in a database, and mostly if they are using MD5 encryption technique, then MD5 is easy to decrypt. But when it comes to private key is a one-time thing. You only encrypt once, and you don't have it's a one-way encryption. So you encrypt once, and you cannot be able to like recover your private key because it's not stored in a database. So that is one advantage. Yeah. So once you have encrypted, the encryption is not stored in a database. Yeah. So we will see how this thing happens. So normally we have, in cryptography, we have encryptions, we have decryption, and we have a cipher, and we have the key. And encryption is the process of turning plain text, the normal text that you can be able to read, into a cipher text, a random sequence of bits, and then decryption is to inverse the process of encryption, while cipher is the mathematical function. That is the cryptographic algorithm, which is used to convert this plain text to cipher text. And then a key is a small amount of information that is required to induce the output of the cryptographic algorithm. So yeah, so we will see and talk about the types of encryption, cryptography, and how they apply in blockchain. Yeah, and the concept of encryption. Yeah. So I hope today's class was interesting, and you had fun. Yeah. And in case someone has a question right now, should be the best time to ask.
Yeah. Hello.
Hello? Yes?
Yeah, today's call is interesting, and
Mm-hmm.
please, I mean, we are beginning to see part of the smart contract,
Yeah.
and the lapses of the initial contract, and how to avoid it, and so on and so forth. I think so far so good. It's okay. Then secondly, the last class slide wasn't uploaded. I don't know if you can help us with that.
Yes, I did upload it. I did upload the videos today. I shared the links today.
Okay,
Let me
okay, I'll
see
check.
if, yeah, I did and also
The assignment.
I created some assignment, so you can go through the assignment. And if you have time, you can go through, make use of like documenting what you have learned, so that you can actually track your progress, and also be able, we can also be able to track your progress also. Yeah. Yeah, so the assignment are not that hard. They are not that hard. So yeah, like the assignment 2 is not that hard, and then assignment 2 was easy. Yeah. So once we dive into smart contract, then by that time we will be able to do a lot. Yeah. So in case you have any question, feel free to reach out. I'm always free. I'm always free in the afternoon, from afternoon, yeah, or up to now 5. I'm always free. So feel free to reach out to me, yeah, in case you have a
Okay, no
question or
problem.
a problem, yeah.
Okay, thanks.
Regarding blockchain.
Sure, sure, sure.
Yeah,
It's
yeah,
okay.
yeah.
Thanks.
Okay, yeah. Do you, Damaris, have a question?
No.
Okay. Hope you enjoyed the class, and yeah. Uh, Comment, Lima, something. Yeah, yeah. So awesome. Have a good night and good evening. Yeah.